Okay, so it goes back to the question number 4. Actually, I have make a mistake, or I didn't mention that over here you see that is 2r 2cr equals to 15. Okay, where does this 2cr comes from? Where we know that is 1 over e naught. So remember, in the graph usually we have, actually when we have the graph is actually 1 over e. It's not 1 over e squared. So if we have this kind of question, if we have 1 over e squared, it means that it's using 2cr. It's not cr anymore, it's 2cr because e is squared. E is squared. Okay, so it's squared number 2 we put on the front of 2cr. Okay, so that's why we have over here is 2cr times by 15. It's not cr equals to, it's not cr equals to 15, it's 2cr because we have 1, the graph given is 1 I naught divided by e squared. Okay, um, another thing is we're going to see, because later on we have question number 14 here using v naught over e squared. Same method will be used. Okay, so if you're given a graph, let's say we're given a graph of 1, let's say 1 I and I over I naught over e. If I naught over e, you just use the top the tau, the time constant equals to cr. If you given we have a number over here, right? So if we're given I and is I naught over e squared, so it will be 2 uh, and then you have number right over here all the time. So 2 tau equals to cr, or 2 cr equals to the number you have on the bottom. Okay, now we continue with the question number 11. So electron of charge E and mass is injected into a uniform magnetic field of flux density within the vacuum. Its initial velocity makes an angle theta with the direction uh, of the velocity. Okay, field shown. Okay, so which of following correctly describe the component of electron velocity parallel to B in the subsequent motion? So what would be the answer? Um, Usha, Usha, what would be your answer?
11 is B.
11.
B.
11 is not B.
Ah, it's A. It's A.
It's A. Why? Why you say it's A? I say it's A because give reason, Usha.
Wait, answer. It is A, but so it's from the rule, right?
Okay. Sheridan, Sheridan,
Uh, uh,
what's your be
it
your
has to be
answer?
perpendicular to B, sir,
It has to be
to the
perpendicular to
magnetic field.
B. Perpendicular to B. Then,
So you
then
have to use cos.
you have to use cos.
Because the electron is a negative charge thing, then but that
Okay. So
uh,
answer is A. Okay. So it's either A or it's either B, right? It's either A or it's either
mm,
B. Okay. Let's see.
yeah.
So it says that electron, there will be saying that a constant speed over here. Constant speed is that will be no F. Okay. There will be no force exerted on the charge, right? So in this case, okay, let's say this is the B and this will be the electron. If the E is perpendicular to the B, it will be having a force or not? If E is perpendicular to B, direction of E perpendicular to B, it will be a force acting on E or zero force acting on E.
Zero.
Zero or yet? 0 or has a magnitude? Which one? Hmm.
It has a
So
magnitude.
this one, yes, yes. Okay, has F, means that it has a force. But if the E is the same direction will be, there no force.
No.
Okay, there will no force acted on the electron. So here, so we have two sides, either cos or sine. So which one saying that F is 0? So F cos,
Cos.
cos. So now say this angle, so cos V cos theta is showing that it was moving in the same direction of B. So answer is
Mm.
A. Okay. So there are two things that making your headache. That is the constant speed over here and V cos theta or V sin theta. Okay. So speed increasing with acceleration and speed increasing with acceleration. This one no, it cannot be because it's parallel. It's not moving in circular motion. Okay. Okay, number 12. A flat circular coil of 100 turns each of 0.06. It's very easy, right? Sheridan, what's your answer?
D.
Answer is donkey or boy.
I'm not sure what's my answer, sir. My paper is downstairs here.
Okay, so it's a circular coil. Circular coil over here. And it has 100 turns. Okay, very easy. And this area, the area over here is A is, what's the area? 0.060 meter. Because it's meter, you don't need to convert into centimeter squared. So we just use
And the answer is D, sir.
answer is D. Just E equals to uh, d flux over dt, and you have a number of coils we call a link flux. So Na change of B over change of T, substitute everything, then you have 0.048 volt. That is D. Okay, answer will be D. Okay, so question number 13. Okay, a sinusoidal alternating current of peak value I pass through a heater of resistance R. What is the mean power output of the heater? Okay, now it's asking for IP, I of the power, instantaneous power, is it? Or peak value I. So IP equals to actually is I naught, right? The peak value, we use I naught usually for naming convention. So heater resistance R. What is the mean power output of heater? So we know that IRMS equals to I naught divided by square root of 2. Right? You know that the I naught, the highest peak I naught, and to convert into IRMS, you just divide it by square root of 2. Right? So one more thing, there is a P output, okay, equals to I square RMS, and this is IRMS times with R, right? Times with R, is times R, P equals to IR equals to IRMS is I divided by square root of 2. This one times 2, and R doesn't have RMS. Remember, R doesn't have RMS, R doesn't have R naught. It doesn't even exist. Okay, so equals to I naught square R divided by 2. Okay. So because I naught over here, we don't see I naught, convert into the question. So I P square R divided by 2. So you have answer is C. Okay, you have the answer is C. Number 14. Okay. Diagram shows the exponential decay of the potential difference charge capacitor 3 mega ohm. Capacitor of capacitor will be, what will be the capacitor of the capacitor? So remember this, we are using V naught over E squared. So when you're using E squared, we are using, this is 2CR. Okay, this is 2CR. So V naught over E square equals to 2 tau, because it is time constant, and equals to 15. So 2 CR equals to 15. So tau equals to time constant equals to 15 divided by 2. So CR equals to 15 divided by 2. C equals to 15 divided by 2R, that equals to 15 divided by 2 times the 3 mega ohm, okay, equals to 2.5 microfarad. Okay, answer will be B. So answer will be B over here. Okay, there. Three identical capacitors are connected as shown in the diagram. Number 15, like the capacitor. So this one, which of following range increasing capacitance? So capacitance increase. Which one is the least? Which one is the least?
Q.
Q is the least, correct. Q will be the least. The second will be R, correct. This will be the second. And third will be the P. Okay, remember? In series, C 1 over C plus 1 over C plus 1 over C. In parallel, C plus C plus C. Okay? Why not? Okay? Any question until this point? Any question, everyone? Until this point? No, ah? Okay. Nice. How to remove your... Okay. How to remove all your drawing? Okay. Number 16, three capacitors of P, Q, and R are connected to a 9-volt battery as shown. Calculate the uh, wait. Calculate the potential difference across capacitor P. How to get the potential difference across the P? So you have to find the potential difference V, potential difference across P, charge of capacitor P, how much the Q charge, and number 3, energy stored in capacitor P. Energy stored in capacitor, oh, the energy E. Okay, oh, everything is on P, right? P, P, P. Okay, so number A, how to do number A? To do number A, remember, if you have a network of capacitor over here, you have to combine these two first. Okay, you have to combine these two capacitor first, then you can proceed with the calculation. So what should we do? We have to combine. If you combine, this is in parallel of series, it will be in parallel. Both are connected in parallel. So parallel is very easy. 5 microfarad plus okay, 5 microfarad plus 6 microfarad. Remember, don't do like me. You should be putting some words on this side, like mm, effective capacitance. Effective capacitance equals to 5 times plus 6. Okay, never do like me. You just write equals to. So 5 equals to plus 6, we have 11 microfarad. So both of the capacitor will combine and making 11 microfarads. Okay. So how much potential across P? Okay. So we can use we call this a potential, no, voltage divider method, right? Where you have V times with R plus R times V back, right? Wait, you have the equals to. Okay, remember this general formula, right? Okay, so V equals to R plus R times V. So we also can use for capacitor. Why we can use for capacitors? Because C equals to uh, no V equals to IR, okay, and C is Q or V, C Q C wait Q Q is CV. Okay, Q equals to V, and V is IR, so it's connected. Okay, so we can substitute this R into Q. No, yeah, into Q. So we have 11 divided by 11 plus 5 and times back with 9. So we end up with 6.19 volts. So exactly number 16 one is 6.19 volts as the answer. Okay. Any question? No. Okay. Remember one more thing. If you have a length of wire, you also can use for substituting the R. Means that L1 divided by L1 plus L2 plus the whole thing. Okay. Also can be used. So this potential divider is actually a ratio of something that when you times back with the whole with the whole EMF or the whole voltage, you can get how much the reflection of it. It's a ratio actually. Okay. So number 17, a potential divider is used to tap a fraction of voltage supplied by a source. Okay. So what is? Oh, so sorry. Uh, A diagram shows a linear variable resistor. Linear means that this one can be increased or decreased the resistor of the of the circuit in use of potential divider to supply variable potential circuit across the circuit. What is function of potential divider? So what is a function of divider? You know the potential divider is potential divider is used to uh, tap a fraction it's not friction, fraction of the voltage supplied by a source. Okay, by a source. So we have here 9 volt. As example, we have 9 volt here. We want to take a fraction of 9 volt. Okay, so that is function of potential divider. B, determine the potential divider difference across the circuit when the sliding as P. So when it goes up to P and it goes up to Q. Okay, 1. When it goes to P, P will be, okay, so if we have a P goes up here directly goes to circuit, okay, because it does not goes into the coil, it goes direct to circuit, there you have 9 volt, right? It doesn't have any resistance, 9 volt, okay. But if it goes to the resistor and everything here to the Q, so it goes back to the 9. Okay, it goes back 9 means that it has 0 voltage. Okay, 0 voltage because we know that when it goes to complete circuit, one complete circuit, it have to be okay 0. Okay, okay. C, the circuit has a resistance of 100. Now we have 100 ohm over here. Calculate the potential difference across circuit when it's under halfway with P and Q. So it's halfway. So 100 is 200 ohm divided by 2. Okay, 200 ohm divided by 2. So I think I can draw another way. So this is 9 volt. This one will be 100 ohm. And this one will be 100 ohm again. Okay. And this circuit also has 100 ohm. And connected like that. Right. So, across the circuit. So you're asking, why is potential different at this side? This. You're asking, what is a V over here? This side. Okay. So what should we do? Okay. Oh, okay. This one. This must be above like this. Okay. This one must be deleted. Okay. So what should we do? We have to combine these two first, A and B here. we combine A and B. So A plus B equals to 1 over 100 plus 1 over 100. There you have it. So it will be 2 over 100. And then you combine with the C. So A plus B plus C equals to uh, 50. If you have your calculation, you have to invert back, right? Because this is 1 over A, right? 1 over A plus 1 over B. So you have 100 divided by 2 and a plus with B, then you have 50. Okay. So potential difference across the circuit is how to get the potential difference across the circuit. So we want this B, only B over here, only B over here. So you use back the potential divider method, V times R plus R plus R times back with B. Okay, so we have 50. Okay, 50. Oh yeah. No. This one. This is A and B only. Okay, this is A and B. A plus B equals to 50. So this one will be, both of them will 50. So again, actually this is equivalent to 50 ohm. Okay, 50 ohm. The both of two. Okay, so now goes back to the how much at this green color. So 50 50 V equals 50 plus 100. Right, we are counting how much measure on 50. So 50 plus divided by 50 plus 100. Okay, V equals to, and then times back the whole thing times with the 9 volt. So the whole thing we have set 3 volt. This one we show you a 3 volt. Okay, so C answer is 3 volt. Any question on this question C?
No, sir.
Kihang, are you okay with C?
Yes.
Okay. So actually the whole thing mostly we are using potential divider formula. You have to remember how one portion divided by the whole portion of the resistance and times back with the power supply. Okay. This sketch how potential difference across circuit varies when the slider move from P to Q. So I think it's very easy. We already made these two numbers. So this one will be the V, the voltage in volt. This is position of slider. So this one will P, this one will be the Q. So this is 9. This one will be the 3. So it goes up like that. Okay, it goes like that. So it will be decreasing. The V will be decreasing. Okay, so we have ended question number 17. Oh, I haven't placed. Yep, question number 18. Okay, so any question? I think we can 25 minutes. Okay, I haven't placed yet the question of 18 and 19 and 20 on the PowerPoint. Okay, uh, I think we tomorrow I continue with 18, 19 and 20. One day with the whole essay question. And tonight I think I'll be giving you the uh, second module test, second paper. Okay, so I give you around 2 days because tomorrow I'm going start to with the essay. So we end the essay in the same time you do the second model paper. After we have finished all the model paper, then we start with the real paper of SCPM. Okay.
Okay, sir.
Okay, so see you tomorrow.
Sir.
Ah,
Yeah, wait. Oh, pardon.
okay ah.
Wait.
Hmm.
The circuit has 100 ohm, right? The
Ah,
circuit has resistance 100 ohm.
okay.
Then
You
why from the potential divider formula we use 50 over 150?
50
What over 150?
50 over 100
Uh,
plus 50.
ah,
Okay. Okay, nice question. So okay. It's easy if I clear this one. I clear this one can? Can I clear all this thing?
yeah.
Okay, so let's go. Let's go back. Okay, this is 9 volt. Okay, this is the 100, right? And then this one will be the 100. So this is 100, this is 100. Goes back to one more 100. Okay. Okay, so one more we are putting the voltmeter at this side. This is the voltmeter. Okay. Now, we need to simplify the circuit first. We cannot use 1, 2 over here and we find out how much the V. We cannot use that. We have to simplify, make it one loop. So this is two loops. It's one over here, one loop, and one more over here. These two loops. You cannot use that. We have to use one loop for the sake of using the potential divider. So to make one loop, very easy. You combine this A and B. If you combine A and B, you know that you have 50 between them, right? So
Or
you have
Uh,
9 volt. So you have 100 over here. This is 100. This one will be 50. So goes back to the 9 volt. So
I
this
understand.
one will be one loop, right?
Yes.
So you use your potential divider 50 divided by 50 plus 100 lah, times back with 9
Yes.
volt.
Okay.
Okay. Okay, see you
So
tomorrow.
start already. Okay.
Tonight I'll giving you the second model. Okay.
okay, sir.
Okay, sir.
Okay, bye.
Thank you, sir.
Bye bye.